Okay, number 12 starts out a little bit differently because it's a fourth degree polynomial, and as we can see, this is definitely not as easy to factor, but we are going to factor it or divide it out in a little bit different way because we are given zeros. So since this is fourth degree, we know that we will have four different possible zeros, whether they be real or imaginary. Right now I know that I have two real zeros at x plus 3 as a factor and x plus 1 is the factor. So since I have this fourth degree polynomial, I can use these linear factors x plus 3 and x plus 1 in order to divide my polynomial. So I'm going to use my first zero of negative 3 and use synthetic division, so substitution, to divide my fourth degree polynomial by this first degree. So when we use our synthetic substitution, we get 0 as a remainder, which we should because we already know that negative 3 is a 0. So I've now gone from a fourth degree polynomial to begin with, this fourth degree, divided it by this first linear factor, degree of 1, so that means my resulting polynomial is now of degree 3. But remember, our goal is to get to a polynomial of degree 2, so I'm going to use my second linear factor of negative 1 for x plus 1 to divide again. So I'm just going to use the same row of numbers and set up a second set of synthetic substitution. And I got 0 as a remainder, which again, as I should, because I know that negative 1 is a 0. And so now I've gone from my third degree polynomial divided by that x to the first, so that means that this solution is a polynomial of degree 2. So I'm going to write that polynomial out. So now I need to see if I can factor this polynomial. So I'll start by factoring out a negative 1, which so far is actually consistent with the fact if I have a negative 1 here, that's a leading coefficient, which is consistent from the original problem where we had a negative in front of the 20 here. Okay, so now what multiplies to 60 and adds to negative 19? When you make your little chart and figure that out, we have negative 15x and negative 4x. Negative 15 times negative 4 multiplies to positive 60, and negative 15 plus negative 4 adds to negative 19. So now we have four terms. We factor by grouping. We can take out a 5x out of the first term, so we're left with 4x minus 3, and a negative 1 out of the second, factor, and left with 4x minus 3. So in factored form, this quadratic becomes negative 1 times the common factor of 4x minus 3 and 5x minus 1. So these are now our remaining two zeros, 4x minus 3 and 5x minus 1. So this is my completely factored form, except I'm going to make one little adjustment. I'm going to make sure that I have my negative 1 in front of this factored form over here because my leading coefficient needs to be negative, so that needs to be consistent with the original and this one. So these are my four zeros. So my first x is equal to negative 3, x is equal to negative 1. Set these equal to 0, we would have x is equal to 3/4 and x is equal to 1/5. So let's determine their multiplicities. Each of these zeros only occur once, so each of their multiplicities will be 1. Since they all have odd multiplicities, they will all pass through the x-axis at their 0 values. Let's plot these zeros. We have negative 3, negative 1, positive 1/5, and positive 3/4. Those points are a little bit smaller, but they're in there. So now we can determine our end behavior by making this little left side, right side chart. So because we have a negative leading coefficient, and actually the leading coefficient, it should be the same whether you're in standard form or factored form. So we had negative 20 to begin with, and then remember when we factored we ended up with a negative 1 outside. So our negative leading coefficient determines that the right side of our graph will end going down. Because we started with a fourth degree polynomial from our standard form, also each of these have a degree of 1, so if you added them you would get 4. We have an even degree, which means that our left side and right side will be doing the same. So if my right side is going down, then my left side is also going down. Let's graph our end behaviors. Now in between, we need to fill in where we change direction, so we need to figure out where our graph crosses the y-axis. In order to do that, we plug in 0 for x and then solve what we get. So when we plug in 0 for x, that cancels everything out of the first part except we're left with just our constant of -9. So our y-intercept is 0, -9. Plot that. Now we can fill in everything in between. So we're going to pass through -3, pass through -1, go down, hit our y-intercept, come back up again, pass through 1/5, and again pass through 3/4. And we're done.